In this video, I'm going to show you how to conduct a two-sample t-test. So this requires data from two samples, and our goal here is to see whether or not they come from two different populations, whether they have two different population means. So we're in the workbook 1213, 1 and 2 sample t-test, and we are in the sheet 2 sample t-test. And as always, you can find the answers in the sheet that says answers in red. A couple things to note here. I have written out the steps here, first of all, that we're going to be doing, so you can refer back up to these if you get lost. And second, I have already done a little bit of the work for you, so I've already input this formula here for the standard error. You're welcome. And I've retained this formula here from last video, when we're just comparing, in this one, we're comparing the critical value of t we're going to calculate with the sample value of t we're going to calculate. Okay, so that's already done. So this is going to give us our decision in step 4. So if we put everything in the appropriate cells up here, as I'm doing in this example, this should, all your numbers should automatically calculate your standard error for you, and then later on your step 4 will be taken care of. So this problem says you want to know whether a one-bedroom apartment costs more in New York City than in Philadelphia. You collect a sample of 17 people from New York City who are living in one-bedroom apartments and find that they pay an average of $3,500 for their monthly rent, with a standard deviation of $1,300. You collect a sample of 20 people living in one-bedroom apartments in Philly and find that they pay an average of $1,100, with a standard deviation of $500. Perform the appropriate hypothesis test at alpha equals 0.0001. So we want to be extra sure that we are correct in this hypothesis test. So step 0, as usual, is listing what we know. What do we know? So we know New York City and we know Philly. Okay, these are our two different cities we're looking at, and we want to know based upon a sample of 17 people from New York and a sample of 20 people living in Philly. And we have means of 3,500 and 1,100. And our sample standard deviation, this is S, we have samples, this is going to be 1,300, and the one for Philadelphia is going to be 500. And our alpha, to make sure we get this right, it's 0.0001. So our first step is to write out our hypotheses. What are we trying to prove here? So we're trying to say that on average, remember our hypothesis tests so far, the 1 sample and the 2 sample t-tests are about averages. On average, one-bedroom apartments cost more in New York City than they do in Philadelphia. So on average, one-bedroom apartments cost more in New York City than they do in Philadelphia. So we can tell right away from this question, do they cost more? We're going to be using a one-tailed t-test. And in symbolic notation, we can say that our mu, I'm just using u here for convenience, mu New York City is greater than mu of Philly. So again, this is just reiterating in some symbolic notation that our population mean is greater than the other population mean. And our null hypothesis is just the same thing here, except on average, one-bedroom apartments don't cost more in New York City than they do in Philadelphia. And here, if they don't cost more, then that means they have to be less than or equal to the population mean of Philadelphia. So our second step is to calculate our degrees of freedom, and this is a stepping stone to our critical T. So our degrees of freedom is n1 plus n2 minus 2. So we have n1 plus n2 minus 2. This is for the two-sample t-test. We have to add two samples, and indicate that we subtract 2 for our degrees of freedom. And our critical T, as we said, this is a one-tailed t-test we're doing here. And our formula for that is T inverse, so the difference between two-tailed and one-tailed. This is one-tailed. Our probability is alpha, comma, and our degrees of freedom is 35. End parentheses, and hit enter. It's a negative value. So we know that this is actually going to be the positive T here. This formula just happens to give you the left-tailed distribution. So if you wanted to put a negative sign in front of it, you can do that. Our formula down below, we can take care of that using absolute values, like in the last video. So our next step, the estimate of the standard error, that's already done for us. You can look at that formula if you want. You can see, for example, the n1 times the s1, which is b16, and s1 is squared, and so on, and so on, and so on. So that's already taken care of. You can use that formula for your assignments and your homeworks. And the sample t, the formula here is x1, x bar 1 minus x bar 2 divided by the standard error. So it's telling us the number of standard deviations we are between x1 and x2. So how do we do that? Parentheses, x bar 1 minus x bar 2 divided by our standard error. And in step 4, you can see that's already done for us. And what this formula is telling us here is that if the absolute value of our sample t is greater than the absolute value of our critical t, so if 7.4 is greater than 4.15, then we go with the research hypothesis. That means that we're more than 4 standard deviations away, and that's very rare that this would happen by random chance if the population means for rent were equal in both cities. And if not, we'd go with the null hypothesis. So we're going with our research hypothesis. So we conclude that H1, on average, one-bedroom apartments cost more in New York City than they do in Philadelphia. And we always want to report the probability that we're wrong when we reject a null hypothesis, and that probability is less than 0.0001. And that is how to conduct a two-sample t-test using Microsoft Excel. And the one thing you want to be careful of for our critical T, if you're using a one-tailed test, use the one-tailed formula. If this was a two-tailed test, is it the same or different, you would use the two-tailed formula.